cosmologists have found obvious proof of what could be an Earth 2.0. This craftsman's delivery shows the rough planet recognized as Proxima B, circling the Proxima Centauri star. It is a game-changer, as space experts have raised a ruckus around town. This is their little glimpse of heaven, another section in cosmology that has opened up. For a really long time, humankind has looked up at the stars, endeavoring to unravel the secrets of the universe. From the beginning of space exploration to the state-of-the-art advancements we utilize today, the journey for answers has never been more earnest. Among the main progressions is the James Webb Space Telescope, JWST, which has now reached another achievement by capturing the clearest picture of Proxima B. This surprising accomplishment raises a significant issue. What precisely makes Proxima B so captivating, and why are researchers so excited about what we've recently uncovered? Proxima has for quite some time been a subject of hypothesis, but recent discoveries have started to reveal insight into its strange potential. This exoplanet, circling Proxima Centauri, the nearest known star to our planetary system, has ignited serious interest because of its location in the so-called Goldilocks zone, where conditions could hypothetically support liquid water. While Proxima B's position offers hope, its real essence remains puzzling. The information currently coming in could offer a deeper understanding of its suitability as a potential habitat for life. The JWST's contribution is something other than a camera overhead. It's an extraordinary device capable of uncovering the most profound mysteries of our universe. This telescope utilizes advanced infrared capabilities, permitting researchers to look through vast dust clouds and see faraway worlds, stars, and planets in ways never before possible. Its accuracy is unrivaled, enabling us to look further back in time, deeper into space, and with far greater clarity than ever before. On account of Proxima B, the JWST's ability to capture minute details of the planet's atmosphere and surface has provided historic information. Yet, what has the JWST disclosed about Proxima B, and how do these discoveries change how we might interpret the planet? This question brings us to a vital point: our investigation of the planet, as well as of the very nature of what makes a planet livable. The discovery of Proxima B's actual qualities, such as its mass, distance from its star, and potential atmospheric conditions, is fundamental, but it's far from the entire story. The planet might lie in the habitable zone of Proxima Centauri, but its future as a potential home for life is anything but guaranteed. The closer proximity to its star means Proxima B is exposed to intense radiation, and its surface might experience extreme temperatures and harsh conditions. These new discoveries give us a chance to assess whether life might actually endure in such a tumultuous climate. The fascinating part, despite these challenges, is that Proxima B's relative closeness to Earth, just 4.2 light-years away, puts it within reach for future exploration. Unlike distant exoplanets, it remains as one of the closest planets that could harbor life, igniting hope that we could one day visit or even communicate with a civilization from this far-off world. While we now have the clearest picture of Proxima B ever taken, researchers are still sorting out what all the data means. From analyzing the planet's atmospheric composition to interpreting whether it has water vapor, every revelation adds another layer to how we might interpret this distant world. However, while we learn more about Proxima B, many questions remain unanswered. Does it have the conditions necessary to support life? Is its atmosphere capable of protecting potential life forms from the intense radiation of Proxima Centauri? And most intriguingly of all, might there be signs of extraterrestrial life, inconspicuously waiting for us to discover? As we explore Proxima B, its significance isn't in that it's within the Goldilocks zone or its potential for supporting life. It's the clues it gives us about the broader universe. The new picture captured by the JWST isn't just an accomplishment in cosmology. It marks a great step forward in how we might interpret planets beyond our solar system and possibly the conditions for life beyond Earth. But why is Proxima's picture so significant, and what does it reveal that we didn't know before? We should focus on the latest discoveries, especially regarding Proxima B's atmosphere. The data from the JWST suggests that this planet may indeed have some form of atmosphere, but its composition remains a mystery. Moreover, the planet's proximity to Proxima Centauri, a flare star, presents challenges for its atmospheric stability. These flares are powerful explosions of energy that could strip away any thin atmosphere, leaving the planet exposed to harsh radiation. In fact, some researchers hypothesize that Proxima B may have lost its atmosphere over time due to these flares, making the planet less hospitable than initially thought. However, this doesn't rule out the possibility of life. After all, We've learned here on Earth that life can survive in some of the most extreme conditions. Take extremophiles, for instance, tiny creatures that thrive in boiling springs, deep-sea vents, and even the harshest deserts. If Earth's extremophiles can endure such extreme conditions, who's to say that life on Proxima B couldn't manage to adapt, even in the face of radiation and extreme temperatures? We should put this into perspective by examining another example of scientific discovery that reshaped how we understand habitability. In 1995, the discovery of exoplanets began to take off, starting with the first confirmed detection of a planet outside our solar system orbiting a sun-like star. Before that revelation, it was believed that Earth-like planets were relatively rare. Fast forward to today, and astronomers have found thousands of exoplanets, many of them in the habitable zone of their stars. These discoveries have shown us that Earth-like planets may not be as rare as once thought. Billions of them exist across the universe. Take, for example, the discovery of Kepler 452b, often called Earth's cousin. This planet, found 1,400 light-years away, orbits in a similar position to Earth. However, it's not identical to Earth. Its location and size suggest it may indeed have liquid water and, potentially, life. This idea has sparked debates about the possibility of life elsewhere in the universe, just as Proxima B is doing now. What's remarkable about these discoveries is that they challenge us to think beyond Earth, to consider how possible it is that we may not be as alone as we once thought. Proxima stands out in this way, not because it's the only planet capable of supporting life, but because its proximity to Earth makes it an excellent candidate for exploration. The hope lies in the fact that Proxima B offers us the opportunity to test our hypotheses about habitability, whether through future space missions or new technological advancements. Proxima B's role in space exploration brings us to the bigger question: how might we explore planets like Proxima B in the future? As we look forward to the next phase of space exploration, Proxima B remains a potential target for future missions. The technology is already within reach. Projects like Breakthrough Starshot, which aims to send probes to Alpha Centauri within decades, are paving the way for and extreme temperatures all create a harsh environment for life. Yet, as we've discovered in extreme environments on Earth, life is nothing if not resilient. The discoveries we've made so far are just the beginning. The JWST has paved the way for understanding the atmospheres, compositions, and potential habitability of planets across the universe, and Proxima is just the first step. As we wrap up the central question posed at the beginning, what does the clearest picture of Proxima B reveal? It has led us to intriguing insights. However, this planet's potential for supporting life remains uncertain. The discoveries it is offering are pivotal in shaping our future missions and guiding the way toward finding extraterrestrial life. Perhaps one day, we'll find that Proxima B, or one of its neighbors, holds the answers we've been seeking. So, what lies ahead for Proxima B and the search for extraterrestrial life? Only time, and the coming age of space exploration, will tell. As we continue our journey to understand Proxima B, it's essential to consider how its discovery fits into the broader context of space exploration and the search for extraterrestrial life. The quest for answers about Proxima B isn't just about understanding one planet, but rather about gaining a clearer view of the larger universe. The more we learn about planets in distant star systems, the more we understand the potential for life to exist beyond Earth. One of the key factors in determining whether a planet can support life is its location within its star's habitable zone. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where conditions are just right, not too hot and not too cold, for liquid water to exist on a planet's surface. This is a critical factor in determining whether a planet could potentially support life as we know it. However, simply being within the habitable zone is not a guarantee that a planet can support life. There are many other factors at play, such as a planet's atmosphere, its magnetic field, its geological activity, and its distance from other celestial bodies that could influence its environment. In the case of Proxima B, its location within the Goldilocks zone of Proxima Centauri is promising, but it's far from the only consideration. The radiation from Proxima Centauri, a flare star, presents significant challenges to the planet's ability to maintain a stable atmosphere and conditions suitable for life. If Proxima B lacks a thick atmosphere or has lost its atmosphere over time due to solar flares, the planet's surface could be exposed to harsh radiation, making it a more inhospitable place than initially thought. This highlights the complexity of determining whether a planet can truly support life, as it requires understanding the interplay between a planet's characteristics and the conditions of its star. As we continue to study Proxima B and other exoplanets in the habitable zone, we are learning more about the factors that make a planet potentially habitable. Proxima B is an important test case for understanding how life might arise and survive on planets orbiting stars very different from our Sun. The data we gather will not only help us understand Proxima B but also inform our search for other Earth-like worlds and our broader quest to answer the age-old question: are we alone in the universe?